Alright, so we are now in chapter 3. Then this chapter 3 is about the Miller Index. So why do we need to study the Miller Index? Because later on in chapter 4 and 5, we'll go through the X-ray crystallography. Okay, X-ray crystallography involve the diffraction pattern. So when you want to convert the real lattice to the reciprocal lattice through the inversion, then this Miller index play a very important role. Okay, therefore, before we move into that chapter, I would try to introduce you this Miller index. All right. So in solid state physics, it's important to be able to specify a plane or a set of plane in the crystal. Okay, so this is normally done by using the Miller indices. So these Miller indices have its own rule to write down the plane. Okay, let's say I want to say this plane. How do I identify this plane, and how do I write the index for this plane? Okay, so the use and definition of these Miller indices are shown in the figure below. Okay, let's say this is one plane. Okay, so I want you to tell me what plane is it. Can you name it? So based on the Miller indices technique, the Miller index for this plane is 233. Okay. Okay, this is how we write the Miller index. HKL bracket. HKL bracket. So you cannot write it as bracket 2, 3, 3. No, this is not the correct way. You also cannot write the square bracket 2, 3, 3. No, okay. The correct way to write is bracket, then let's say the first number, the second number, the third number, that bracket. That's all. There's no comma. Then the bracket cannot be used like a square bracket or any other bracket. No, only the bracket. Okay, then how to determine the Miller index for this plane? Okay, very simple. The value for A is 3, right? The value for B, 2. The value for C, 3. Okay, so the bracket 1 over A, no comma, sorry, 1 over A, 1 over B, 1 over C. What we get? This is 2. You get 1 over 3, 1 over 2, 1 over 2, right? So you want to get an integer. So how to get an integer? You can time 3 over 2 for each number here. So this one times this one, you get, no, not times 3 over 2, but times 6, right? We can times 6, sorry, and times 6. So when we times 6, then you get 2, 3, 3. Then you will get an integer. Okay, let's say just now you have times 3 over 2. What I get? I get 1 over 2, 3 over 4, and 3 over 4. This is not correct. Okay, not correct. You want to get an integer. You want to get an integer, then you have to times 6. You have to times 6, then you get 2, 3, 3. 1 over 3 times 6, you get 2. 1 over 2 times 6, you get 3. 1 over 2 times 6, you get 3. So I will get this Miller index for this plane. Okay, I repeat again. I want to get the Miller index for this plane. Okay, so I want to get A equal to 3, B equal to 2, C equal to 2. Okay, the proper way to write the Miller index is HKL, and then all HKL must be integer. So we know that H equal to 1 over A, K equal to 1 over B, L equal to 1 over C. So 1 over A equal to 1 over A equal to 3, 1 over B equal to 2, 1 over 2, C 1 over 2. But then this is not integer, okay? We want to get an integer, so we have to times 6 for all this number. So 6 times 1 over 3, we get 2. 6 times 1 over 2, we get 3. 6 times 1 over 2, we get 3. So the Miller index for this plane is 2, 3, 3. Okay, easy, right? So the Miller indices for this plane is 2, 3, 3. So Miller indices HKL is an index system to specify a plane. So Miller indices we normally write as square, not square, but bracket HKL. So these Miller indices can be used for the determination of position and orientation of crystal plane. And we need to know the coordinate of any 3 pointers in a crystal plane. Okay, let's say just now, you need to know the coordinate of any 3 points. Then you get point A 3, point B 2, point C 2. So we need to know these 3 points. Then only we can convert it into the HKL. So consider the cubic lattice with A equal to B equal to C, and then all the angle equal to 90 degrees. Then consider a plane that intersect the A, B, C axis at vector point A, B over 2 and C over 3 respectively. So now you have A. So this point is, you neglect this one, this point A, and then B is B over 2. This point is B over 2, and then the other point is C over 3. This point is C over 3, right? C over 3. Then you have to find the Miller indices. How? Bracket HKL. So this bracket 1 over A over 2, 1 over B over 2, 1 over C over 3. Then we get 2, 2, 3, right? It's 1, 1, 1. So the answer for this one would be 2. No, sorry, again, come again. Sorry. I get it wrong. Okay, this is A, 1 over 1. And this is 1 over 2. This is 1 over 3. So we get 1, 2, 3. Yeah, the correct one is 1, 2, 3. Okay, oh, actually it's here. So A equal to 1, B equal to half, like the previous case, and then C equal to 1 over 3. Okay, so the plane is defined as HKL, where HKL are the reciprocal of the intercept of the plane on the axis ABC, reduced to 3 integral having the same ratio. A equal to 1, B equal to half, C equal to 1 over 3. So the Miller index HKL, you can write 1 over A, 1 over B.